Hello everyone, this is the part E of the tutorial series Multi-Topic Text Classification with Various Deep Learning Models. You might remember that in the previous chapters we already covered the basics of text classification. Then we have executed exploratory data analysis on the sample dataset. We already prepared the dataset. And lastly, we already prepared our train, test, and validation datasets by using TensorFlow data pipeline and Keras TextVectorization. Today, in that tutorial, we are gonna implement a deep learning model, especially a feed-forward network, using an embedding layer. This embedding layer will be Keras embedding layer. So in that tutorial, we will begin to use the dataset that we have prepared in the previous tutorials in various deep learning models. Before delving into today's topic, I would like to introduce my channel briefly. At the Murat Karakay Academy YouTube channel, I share tutorials with source codes in English and in Turkish about artificial intelligence, especially how to implement deep learning and machine learning approaches with Python using scikit-learn, TensorFlow, and Keras libraries. If you are interested in artificial intelligence, deep learning, or machine learning, and if you are looking for theoretical and practical information, please subscribe to my channel and activate notifications. When you subscribe to the channel and activate the notifications, you will be notified of live broadcasts and newly uploaded content. Now, let's continue with today's topic. This is a live broadcasting, so if you have any questions, you can just write your questions into the chat screen. So I would like to answer your questions immediately. However, if you watch this video after the live broadcasting, live streaming, you can write your questions or comments. So let's continue with today's topic. So in this part, we will use a Keras embedding layer in a feed-forward network. It means that we are not gonna use a recurrent neural network or a transformer structure. During training of the model, we will train this embedding layer as well. As you might remember that we have already introduced the embedding concept at part A. You can review the details of embedding and how deep learning models applies it for text classification in the following Murat Karakaya Academy YouTube playlist. I already shared all the necessary links in the video descriptions. If you are not familiar with the classification with deep learning topic, you can find the 5-part tutorials useful in these links. However, in this tutorial, I will try to do my best to introduce these topics to you and use them in the places that we need them. In that tutorial, we are going to create a basic deep learning model that will use an embedding layer as the initial layer, and then a couple of dense layers for classification as seen in that figure. So here we will provide the text dataset, then tokenize this text dataset or the comments or the reviews into some word tokenization. After that, we will provide these tokens to the Keras embedding layer. Keras embedding layer will convert the words, integers, let me say word identifiers in the dictionary, to some higher dimensional vector format representation. Then the hidden layers and the output layer will convert to this classification probability. Using this softmax layer, we will use these logits and convert these logits to softmax layer to predict the classify. So here I would like to remind that the embedding layer will be trained immediately during the training of that model as well. So the embedding layer will learn how to transform an integer for a word to a higher dimensional vector, such that the model will increase its accuracy in classification of the given text into some classify classes. So remember that in the previous part D, we already built a TensorFlow data pipeline and we apply Keras TextVectorization layer for text preprocessing and tokenization. And we adapted the Keras TextVectorization layer onto the train dataset. Then, after adapting, we apply this layer and create the train, validation, and test datasets. At the end, remember that we already finalized or optimized, configured TensorFlow data pipeline. Remember that from the previous part, we already, at the end of the previous part, we already have the train, validation, and test datasets. In that tutorial, we are going to use these datasets. Let's continue. So, I would like to remind you how to use the Keras embedding layer in general. Keras embedding layer turns positive integer indices into dense vectors of fixed size. So these integers generated by the Keras TextVectorization layer. Remember that the output of the text vectorization layer is a dictionary. In that dictionary, for each token, there is a corresponding integer indices. So the Keras embedding layer will take these integers and convert to a dense vector representation. The numbers in that dense vector will be learned throughout the training of the whole model. So the important arguments of the Keras embedding layer are these. The first one is input dimension. It's the integer value that we are going to provide. This is the size of the vocabulary. So the maximum integer index in that vocabulary plus 1. Remember that we already created our vocabulary. And the second thing is that output dimension. So the output dimension determines the dimension of the dense embedding. So that's the output of the embedding layer. How many numbers will be in the representation of each token. So that's the dimension of the output. The third important parameter is the input length to that layer. So that's the length of the input sequence. Remember that in the previous part, we already decided and fixed this with 40 tokens. So it's a constant for our case. When it's constant, we can give this number to the input length parameter of the Keras embedding layer. This argument is required if you are going to connect the flattened and then dense layer upstream following the Keras embedding layer. Without it, so if you don't provide this fixed number, if you don't provide, the shape of the dense outputs cannot be computed. Therefore, we provide this. So the Keras embedding layer will receive an input shape in 2 dimensions tensor, like batch size and input length. The output of this layer will be a 3-dimensional tensor with the shape batch size, input length, and output dimension. Basically, it will get a sequence of integers and it will output a sequence of vectors. Each of them is output dimension. If you would like to learn more about the Keras embedding layer, you can visit the Keras official website, or you can watch my tutorials on my Murat Karakaya Academy YouTube channel. Now, after remembering or learning the Keras embedding layer, we can now create our simple deep learning model. Here I will use the Keras functional API to build the model. You can learn the details of this API here. In the previous part, we already created, remember that, the dictionary by using Keras TextVectorization layer. Here, in the previous part, we already decided that the fixed size integers to represent the comments, it is the max_len parameter. So remember that it is 40 tokens. So the input layer of the model would expect a sequence of max_len integers. Here you notice that our first layers in the model is input layer. In that input layer, we just stated here that the sequences will be fixed and equal to max_len length, which is 40. The second thing that we already decided in the previous part, the size of the dictionary, which is vocabulary size. So we will use this parameter, vocabulary size, to set up the embedding layer. Here, if you like that, if you check that the embedding layer, the parameter of the embedding layer, first parameter is input dimension is initiated with vocabulary size. It was 100K, remember? Okay, as a last reminder, during part B, EDA of the dataset, we learned that there are 32 different classes in our dataset. So we already stored this in number of categories variable. So we are going to use this here in the last layer, so that there will be number of categories neurons in the last classification layer of the model as the outputs of the logics. Let's look at our model step by step. So the embedding dimension is 16. You can use larger values or smaller values to represent each token. But please note that if you use larger values, it means that you need more computation power and memory to represent these numbers, these integer numbers corresponding to the tokens, the words. It will help to associate some meaningful representation to each token, but on the negative side, you will need more computation power and memory. If you use smaller values for embedding dimension, then it means that you are maybe losing some information relating the token with other tokens or the content. So you need to understand the importance of this parameter value, and maybe you need to try and see the best or the optimum value for your case. Then this is the feed forward dimension. This is the number of hidden neurons in the model. You can set up different numbers. By using this function, I will create a deep learning model and return it as a result. The first layer of the model will be the input layer. Input layer will expect to get a sequence of max_len in batches. In this sequence, there will be integers. In the second layer, I first define the embedding layer by giving the parameter values. The input dimension will be the vocabulary size. The output dimension will be the embedding dimension. We already decided as 16. Input length will be the max_len. We already decided in the previous part. Then, after defining this embedding layer, we can now apply this embedding layer onto input tokens that we received as an input. Then we can flatten the output from 3-dimension to single dimension, and by using another dense layer, the hidden layer here, we can create a representation again. After that, we can apply the dropout to avoid the overfitting. After that, as the last layer, as a classification layer, we have the number of categories. So it means that we have such number of neurons. Each will output some logits, some numbers, and then we can use these numbers to predict the class probabilities. Here, by using the functional API, we can put together the inputs, the outputs, and we can give a name to that model feed-forward network. We can define the loss function here. The loss function will be sparse categorical cross entropy. Why? Because remember that we represent the correct class by just a single integer, not a one-hot encoding. Therefore, it will be sparse categorical cross entropy. And from logits will be true because in the last layer we didn't apply any activation function such as softmax. So the sparse categorical cross entropy will apply the softmax by itself. So for the metric, we are gonna use the, of course, sparse categorical accuracy metric. Then we can compile our model by providing the optimizer, loss, and metrics functions. And we return the model. Let me check if we have any questions so far. Okay, so far we don't have any questions or comments. If you are watching this video while live streaming, please share your comments or questions. So I would like to answer you immediately. Okay, now here as you see that by calling the function, I create my model FFN, and then we can get a summary of the model. You see that we have the input, we have the embedding layer, then we flatten this 3-dimensional into 2-dimensional, and then we apply the dense on it with 64 neurons, and we apply dropout, and as a last layer, classification layer, we have 32 neurons because we have 32 classes in the problem. We can also check this model as a figure, as a plot. So we have the input, embedding, flatten, dense, dropout, and the classification layer. Of course, you can change this architecture by adding different layers or adding more dense layers or adding some other, for example, LSTM layers. I will talk about these different architectures in the upcoming parts. Okay. The training of this model will be easy because we already prepared train, validation, and test data sets in the previous part. So I will not go into details this, and I will just show you how to do this by using the fit method of the model object. We are gonna provide the train data set, validation data set, and I just run here 7 epochs. You can run different epochs, of course. And I set the variables to see the details of the training process. After 7 epochs, attention to the validation sparse categorical accuracy is increasing, and also notice that validation loss gets lower values. And then you can check the, if you like, the accuracy of the model in the training according to train dataset and validation dataset. Here you notice that. You see that if you increase the epochs numbers, the train dataset accuracy is still increasing, but you see that the validation datasets accuracy has a plateau here, flatten here. So basically you would argue that after the epoch 3, there is a overfitting. And similarly, if you plot the loss values according to the data sets, train and validation, you notice that after the third epoch, the loss with train dataset gets better. However, after the third epoch, the loss for the validation dataset is linear, almost doesn't change. So you can argue that after epoch 3, the overfitting phenomenon is observed. I will not get into the details of the underfit, overfit, or the hyperparameter tuning, because I will talk these matters in part K of this tutorial series. So in part K, I will provide you more information about hyperparameter optimization tuning, underfitting and overfitting situations, phenomena. Here I will just want to warn you about this. Okay. After training a model, it's a good custom to save the trained model, because it takes a lot of time in real life to train a model. So it's a good idea to save the model and then load the model, the trained model, whenever you need it for some usage. I have some tutorials about saving and loading TensorFlow Keras models, even with custom layers, custom functions. You can watch these videos as well. So basically here, to load the model again, you can use the TensorFlow Keras models dot save model function. Now, after training the model, after observing the accuracy, actually we would like accuracy on the training and validation data. Now we can check the accuracy on test data set. So basically you can use the model's evaluate function, and the evaluate function will return us the loss and accuracy on that test data set. Here you notice that the test accuracy is very similar to the validation accuracy, 89%. And you can also apply some predictions on the test data by using the predict method of the model. Then you can get the predictions and you can get the actual values from the test data set. Remember that in the test data set, we have used the TensorFlow data pipeline. So in that data pipeline, we just put X and Y values, the inputs and the target values together. So we need to batch these. So we need to unbatch the test data set, and we get only the correct values, the Y values as actuals. So after getting the predictions and the actual values, now we can measure the performance of our trained model in details. Here I would like to mention that only looking at the accuracy values for a multi-class classification is not enough. So you need to be careful about this. Please use these two methods that I am going to show you immediately in your experiments. The first thing that you would like to see, a classification report. So in that classification report, you will see different results for different metrics. The most important metrics for the classification nowadays are precision, recall, F1, along with the accuracy. But you need to understand how to use precision, recall, F1, and accuracy metrics appropriately. And these metrics will be reported for each class, not for an average only, but for each class. And the report also provides you some averages over the classes for different approaches. Macro average, weighted average, sample average, and the micro averages are 4 different average approaches over the classes. So you need to understand which one is good or representative for your case. You need to understand this. Here I provided the several short explanations. I will not go into the details of them, but basically I would like you warn about this. Please pay attention and pay some time to learn the metrics, precision recall F1 score along with accuracy, because accuracy is not enough alone. I have a tutorial why 99% accuracy is not enough titled. So you can check this video tutorial, understand that especially for unbalanced data sets or for multi-class data sets, the average is not enough and will not tell you the truth about the success of your model. You need to check precision, recall, F1 score. Actually, there are more scores like area under curve scores or receiver operator characteristic ROC score. You need to use all these scores to understand fairly your model performance. Here I will show you how to get these results easily. You can use scikit-learn metrics class, and in that metrics class you have the classification report function, which basically takes actuals and predictions. Then it will report you these 3 metrics for each class, and it provides you the support. Support means that the number of samples in here. So we are talking about test data set. Here you see that in test data set we have a balanced distribution of the classes, we can say this. And notice that here we have 32 classes. Remember, it begins from 0. And if you check the, for example, F1 score, some classes have lower F1 score, some classes have higher F1 score. So you might work on this class, for example, class 7, to increase its F1 score, or check that this class has very low precision value. So you might learn a lot of things about your classifier per classes, and you might need to take some actions to increase precision recall F1 score depending on your target application priorities. I will not go into details this, but I just warn you that pay attention for each class result. Here you have the accuracy value, average accuracy over the classes, and then you have some average values for precision, recall, and F1 scores. Here you have the macro average, here you have the weighted average. So I suggest you again to learn these metrics in detail. I cannot give the details here because it's a very deep subject, but I will suggest you these tutorials. You see that in English and in Turkish I provided you several tutorials to teach or to learn these metrics and these averages according to some situations, like when you have the imbalanced data sets or when you have the multi-class data sets. So please go over these tutorials to improve your skills. The second thing that you can use to understand your model performance is to generate a confusion matrix. So a confusion matrix is used to know the performance of a machine learning model at classification. The results are presented in a matrix form, so the name comes from that. Confusion matrix gives a comparison between actual and predicted values. the numbers on the diagonal of the matrix are the numbers of the corrected predictions. We can use the scikit-learn matrix class and we can import the confusion matrix method. Here we provide the actuals and predictions. We can get the confusion matrix from here by using the some pandas data frame easily. Here I will show you the confusion matrix as the pandas data frame. If you look at that on the rows, it provides the labels of the classes. In the diagonals, we have the labels of classes. Here, as you see that this is the correct label. In the columns, you see the predicted classes of these class. So you see that about 2200 samples are correctly predicted, but 2 of the samples are predicted as the second class. 5 of the samples from that class predicted as the third class. So basically you can see the distribution of your predictions over the classes. You can check the correct classification on the diagonal of that matrix. Others shows you your misclassification numbers. Again, if you check these first class, you would see that most of these errors, for example 37 misclassified, goes to that class. So you can see in details how your model perform in classification with respect to misclassification distribution over the labels. You might take some actions again. So I will go down and I will show you how to visualize these in different ways. I will show now how can we, instead of using nominal values, the number of the samples, I will show the ratios of the predictions over the classes. Here you see that we can see on the diagonal the correct classified samples, percentage of the samples, and you can see that misclassified sample percentages, and you can check that here, for example, we have many misclassified, 1.3% of the samples of these class misclassified on the 1, 2, 3, 4, 5, 6, 7, 8 class. So also you can check that for that class our accuracy is very low compared to other classes predictions. Okay, so this will help you a lot to understand your model performance. Let me check that if you have any questions so far. So I cannot see any questions so far. Okay, I will stop at this moment. We have reached the end of the tutorial. In that part, we created a deep learning model with an embedding layer to classify text into multi-classes. We trained and tested the model. We observed the model performance using classification report, confusion matrix. We pointed out the importance of the balanced data set and performance on each class. In the next part, we will design another deep learning model by using a one-dimensional convolutional layer. I hope that you like this tutorial. If it is so, please click the like button. Please share this tutorial. And please do not forget to subscribe to the channel. I hope to see you in the next tutorial. Take care. Bye bye.